Okay, so here's how we work this one out. We start with realizing that this is an angle, so theta is the arc sine. Okay, and that sine of theta would have to be u of x. Okay, now let's differentiate this function here. And eventually what we're trying to find is d theta dx, because that would be the derivative of the arc sine. So if you differentiate this, you'll get on the left side and on the right side, derivative of the sine is a cosine, but we assume theta is a function, so we need d theta dx. The right side, we just have a u prime of x, and then we divide by cosine, we get this. Now from our diagram over here, I drew that as soon as I realized this right here, which came from letting theta be this, and I just rewrote it. So sine of theta was u of x over 1. So think of that as a 1 underneath there. And from there, Pythagorean theorem gives us this, this missing side over here, which enables us to put the cosine in down here. And this is our answer then. So what that tells us is that the derivative of the arc sine of u of x is just going to be u prime of x over the square root of 1 minus u of x squared. Now, if u of x just happens to be an x, then all of this reduces to just 1 over 1 minus x squared. So we get a nice result. So some students will just remember that just plain old arc sine of x here will be equal to 1 over square root of 1 minus x squared. It's an easy result to remember.